Well, howdy, folks, and we are at the end of our discussion of naming organic compounds. And just to give us a brief overview, right? We said, hey, we have organic compounds. What are organic? Organic means what? I have carbon, and these are covalently bonded, but it is not oxides. So things like carbon dioxide we exclude, and carbonates we exclude. So that's generally what an organic compound is. And then we said we want to focus on something called a hydrocarbon. And what are hydrocarbons? Well, they are just organic compounds which contain, hey, hydrogen and carbon. Wow. Okay, and then we said we have three types of hydrocarbons that we want to discuss. We want to discuss alkanes, alkenes, and alkynes. And what's the difference? Well, alkanes all have single bonds between my carbons. Alkenes have at least one double bond between the carbons, and alkynes have at least one triple bond between the carbons. And then we talked about how we name each of these, and it's a pretty simple naming process, right? We put a prefix, which has to do with the number of carbons, and then we add ane for alkanes. We use our prefix plus ene for alkenes, and we use our prefix plus ine for alkynes. And what are our prefixes? Well, 1, we use meth, 2, eth, 3, prop, 4, bute, 5, pent, 6, hex, 7, hept, 8, oct, 9, known, and 10, dec. And so then I can take any one of these prefixes and put one of those suffixes on, and I get decene. And that is what? What is decene? That means I'd have 10 carbons. Oh my, why did I pick 10? Yikes, I don't even know if I can count that high. And there has to be at least one double bond in there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yikes, 10. There we go. There's 10 carbons. I have one double bond on it. And then the rest of this thing would have what? Hydrogens on it. And so that would be decene, correct? Now, to name that properly, I'd want to identify the number of carbon on which this double bond is. And it's on the 1, 2, 3, 4. So I'd call this what? 4-decene. That means I have 10 carbons, one double bond somewhere. Where is it? It's on the fourth. Good. So let us move forward beyond that and talk about something like this. Consider the following molecule. Is it an aldehyde, a carboxylic acid? Wow, carboxylic acid. Look at that word. Ester, that's like my aunt, isn't it? And ketone, I don't even know what a ketone is. Well, yes, I do know what a ketone is, and I'm going to teach you here in a second. These things are called what? Functional organic groups. Yikes. Functional organic groups. Okay, now, you know how I am. I love to start off with a definition. Now, let me tell you right off the top, I don't care if you guys know this definition. I'm never going to ask it. I don't know if anybody's ever going to ask it, but it helps us to understand what something is when we know the definition. So what is a functional organic group? It is a group of atoms in an organic compound. And these groups do what? They cause the molecule to act in a specific way, regardless of the size of the molecule, regardless of molecule size. That's a rough definition. Now, what do we mean by that? Let's say I have something that has a couple carbons on it, hydrogen, hydrogen, right? We got our hydrogens here. And instead of having a hydrogen at the end, it has an OH. Well, this is what we call an alcohol group, and so this thing has certain characteristics. Now, if I had like 7, 1, 2, 3, 4, 5, 6, 7 carbons, and it ends in an OH, because of the OH, these guys are going to behave in many ways similarly. They're going to have a characteristic behavior, and that characteristic behavior is caused by the OH, meaning they both act like alcohols. Good. That's the definition. Now, do I really care that you know that? No. So let's forget it. Well, not forget it. Let's just not remember it. That sounds like the same thing. Yes, it is. Okay. I don't really care whether you know it or not. Here's what I care about. Can you identify functional organic groups? Now, the way I do it is I kind of break my functional organic groups down into two general types. There are those that contain oxygens and those which contain nitrogens. That's the way I look at it. Now, when I break that down further, not only are there some that contain oxygens, but there are some in which the oxygen is single bonded to a carbon, and there are others where the oxygen is double bonded to a carbon. That's how I start getting my ideas organized on these functional groups. So, first one, let's just look at an OH. An OH bonded to a carbon. This is what we call an alcohol, such as CH3 with an OH on it. That's what we'd call methanol. So this is one group. The other one is where I have a carbon bonded singly to an oxygen, bonded singly into my carbon. This is what we call an ether. Good, such as C with 3 H's here, O, C, 3 H's. We'd call this thing right here an ether. That's my functional group. So those are my two functional groups that have single bonded oxygens. How about my double bonded? Well, I like to start with a carbon double bonded to an oxygen with carbons on either side of that. This is what we call a ketone. All right, and a typical one would be something like this. This is one of your, well, this is probably your smallest ketone, and I look for carbon, 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 double bonded to an oxygen. That's my ketone. Now, what if I get rid of the carbon on one side, and so I have a carbon with a carbon, double bonded oxygen, and then an H here, right? We call this an aldehyde. Aldehyde. All the hides in the house go HO. Good. So aldehydes, right? And so here's a typical aldehyde like this. And I'm looking for this double bonded oxygen bonded to a carbon with a hydrogen that is terminal on the end. Good. What about something that goes like a C double bonded to an O with an OH? Now, that looks to me kind of like an alcohol, but since it has this whole thing like this, and here's a carbon over here, that's not called an alcohol. We call this a carboxylic acid. That's a carboxylic acid. So something like this, CH3COOH, would be a carboxylic acid. That is what? Acetic acid. Good. And then let's see, I think 1, 2, 3, 4, that looks pretty good to me. I may be forgetting one. Oh, I'm forgetting our ester, my ant, right? My ant. So here's an ester. In an ester, I have this kind of an arrangement. Carbon double bonded to an oxygen, and that same carbon is also bonded to an oxygen. That is an ester. And we know esters, right? Polyesters. Polyesters mean that you'd have this thing repeated over and over and over again. So those are my 4 double bonded. Now, what about my nitrogens? We only have 2 nitrogens to worry about. We have the one that looks like this, where I have a carbon bonded to a nitrogen, and the nitrogen has 2 hydrogens on that. We call that an amine. And then the other one is a carbon double bonded to my oxygen, and then a nitrogen on it, like that. And we would call this an amide. So those are the functional groups I want you to know. Here's a table of them right here. I don't care about the suffixes. or the naming. All I really want you to be able to do is identify these, okay? Identify those down here, the amide, the ester, the carboxylic acid, ketone, aldehyde, amine. We don't even care about the haloalkane. Back to our question. Wow, do we really have a question here somewhere, Mr. Smith? Yes, we do. Here it is. Okay, I want to identify what is this? Well, I find my carbon here. I have a carbon. It's double bonded to an oxygen, and then it ends in an OH. Okay, so carbon double bonded to an oxygen. So I'm looking at my double bonded oxygens here, and double bonded oxygen ends in an OH. Is it a ketone? No, a ketone has a carbon here. An aldehyde has an H here. Oh, here we go. What is that? It's an O double bonded to carbon, single bonded to an OH. That is an, oh, not an carboxylic acid. So my answer here is it is a carboxylic acid. Great. Next one. Consider this molecule. All right, you guys do this one. Let me know when you have the answer. All right, what am I looking for? I'm looking for something kind of different here. I'm looking for an O double bonded to a carbon, and that is then bonded to an O, and then other carbons over here, right? Okay, let's go back and look at our notes. I have O double bonded to a carbon, okay, but then it's double bonded, then single bonded to an O, so it's not a ketone. It's not an aldehyde. Well, could it be a carboxylic acid? Well, carboxylic acid goes O double bond carbon, oxygen, and then hydrogen. Is that what we had? No, 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 no. I have a O double bonded carbon, oxygen, and then another carbon. So what must that be? That must be what? An ester. Yes, you're right. If you said ester, you have it right. Yay. Let's put a smiley face and give it some hair. Cool. You know, I'll wave at you. Hey, hey, I'll give you a big foot. Moving on. Next. Consider the following molecule. Is this an alcohol or an ether? Okay, what do you think? Well, it has an OH on it. An OH is what? Alcohol. Good. Alcohol. Great. Next. You guys do this one. Is this an alcohol or an ether? Piece of cake, right? We know when alcohol ends in OH. This guy has a C, O, C. That can't be an alcohol, so that must mean it is an ether. Great. And we're almost done. Here it is. Okay, an amide or an amide. Both these am things mean they have what? They have nitrogen in them. This one looks like what? I have a carbon double bonded to an oxygen, bonded to a nitrogen with an NH2. So we're looking at, if I turn it this way, I don't know, I just seem to like looking at these more along this way, right? So if I look at it this way, what do I have? I have carbon double bonded oxygen, nitrogen. What is that? Is that your amine or your amine or your amide? Well, let's go back and check. Have we memorized these yet? Not quite. Let's look down here. I have a carbon going directly to a nitrogen. That's an amine. But this is what? Oh, here we go. Carbon, double bonded oxygen, nitrogen. That is an amide. Cool. Amide. Where is it? Amide. That's our answer. And the last one, piece of cake. I have a carbon to my nitrogen and hydrogen. Nothing but hydrogens here. This has to be not the amide, but the amine. Got it? All right. Now, like I say, I don't expect you to be able to name these. All I want you to be able to do is if I draw something like CH, C double bond O, excuse me, if I draw CH, double bond O, OH, you guys look at that and say, okay, I see a carbon, I see an OH and an O, that must be a carboxylic acid. That's what I want you to be able to do. All right, good. Well, I think, yeah, look at that, we're done. That is the end of our discussion of organic nomenclature. Good luck, test coming up. See ya. And so it goes.